Now, machine learning is really the core of AI and specifically the core of platform-oriented business models. So I'll say a little bit more about it than maybe some of the other technologies. And it's also a very broad and kind of sweeping category in the world of AI. In general, machine learning refers to analytical approaches, kind of analytics on steroids, if you will, that can improve, not typically continuously, but episodically with human intervention each time. They can improve at their task or the decision they're trying to make using new data. The task that it's trying to perform is typically prediction, sometimes classification as well. Machine learning can deal with structured data. Typically, when we say structured data, we mean rows and columns of numbers, and unstructured data like images and voice recordings and so on. There are a variety of different types of machine learning. You hear about supervised and unsupervised and reinforcement and so on. By far, the most common in business is supervised learning, which learns from some training data. And then you can also classify machine learning in terms of the types of algorithms used, and there are a lot of them, more than 100 different possibilities, from things that are very simple, like regression, to much more complex analytics involving support vector machines and neural networks and so on. I won't go into detail on those, but sometimes they even get combined. It's important to keep in mind it's always statistical in nature. These are statistical models that are being generated and applied. Now, at its very simplest, this is a common thing to do. And so I have here a picture of the factors that are used in a credit score, which many of you may be familiar with. It's used in most countries around the world to determine, are we worthy of a bank or a credit card company giving us some credit. And so the simplest form of machine learning would be to say, okay, I'm going to run a linear regression equation on part of my data, we'll call that the training data set, where I know has that customer group actually paid me back, have they been good credit risk. And then you use the resulting model. Typically, you would also validate that on another data set. But once you have a model that you're happy with and is validated, you would then score, as it's often called, or predict other cases where you don't know the outcome variable. You don't know whether the person will pay you back or not. And credit score models have been around for about 30 years or so in the United States. There are a lot of people who talk about predictive analytics. Predictive analytics and machine learning are basically the same thing. And so it's using data for which we already know the outcome to predict other data environments where we don't know the outcome we're seeking to predict or classify. So it can be very simple. On the other hand, it can be very complex. Deep learning is one form of neural network, and neural networks are one approach to machine learning. So we kind of have multiple layers of this technology. Deep doesn't mean profound or really smart. It just means there are multiple levels of features or variables. Features are what we call variables in machine learning. I'm not sure why exactly. Somehow that term changed along the way. The goal of deep learning is still to predict, or somewhat more commonly than in traditional machine learning, to classify. Is this a picture of a cat on the internet or not? One of humankind's greatest achievements was to figure out a picture of a cat. Is it a cat or not? And this particular technology is quite well suited to things like image recognition and speech recognition. It typically requires a lot, in many cases, thousands or millions of labeled data. This is actually a cat, and it can only learn about it in that way. These are very popular today. People are very excited about this technology, but it can't do everything, and It can be easily manipulated and confused, if you will. And because these models are so complex and so kind of black box oriented, virtually impossible to interpret them even by a really smart data scientist or regulate them. So you're not going to see them all that often in highly regulated environments like financial services or healthcare. So this may look like a somewhat complex model, but it's actually a simple deep learning model with only 3 layers between the inputs and the outputs. So it does kind of look like a model of how the brain might process information with individual neurons and links between them. So that's where the neural network analogy came. Most people say it's not really much more than a metaphor. The brain is much more complex, and in many cases, we don't even understand how the brain perceives and makes decisions. But this is a simple picture of a deep learning model. So you start to see how it might be very complex to interpret, and the features or variables, these nodes in the layers, in many cases are quite abstract. They don't correspond to anything in real life. So if you're looking at a picture of a cat, one of those variables or features doesn't necessarily say, fuzzy face or 2 eyes or 2 points for ears. It's much more complex and abstract than that. Neural networks and deep learning are getting better all the time, and they're in many circumstances, they're better than a human at many simple image recognition tasks. And there's a image database called ImageNet, and a kind of an annual competition to see how well can these models do in identifying images, and they've gotten better than humans in many cases already on simple visual images. But if it's a complex visual image where a lot of things are going on, typically not as good, can be easily tricked by small changes in the image. It's not uncommon. I showed you a model with 3 intermediate layers. It's not uncommon to see 150 different layers and thousands of features. And some models even have thousands of layers and multiple thousands of features. We found that these models run really well on a technology that was originally invented for another purpose, kind of drawing images and things like video games. We call them graphics processing units, and it turns out they do a very good job of running deep learning models quite quickly and accurately. So companies like NVIDIA, who make those kinds of processors, have really prospered because of deep learning. So there are a lot of different ways that we can use this technology. Platforms increasingly are using deep learning, particularly for speech and image recognition. We see it a lot in financial services, but only in non-regulated components. So if a bank wants to look at whether you have an image of a piggy bank on your Instagram site, they could probably get away with using it. But if they want to deny you credit on the basis of a deep learning model, probably the regulators are not going to go along with that. All of the image recognition in autonomous vehicles is done with this technology. We're starting to see them for radiology image recognition in healthcare, although it's early days for that. Oriented advertising uses them a lot. And then in addition to various industries, we also see it in a whole variety of functions. Marketing makes particular use of image recognition, some in finance and information technology to identify really kind of complex problems, supply chain, et cetera, et cetera. So this is a powerful technology that is increasingly popular in the world of AI. Now, there are a number of strengths. It can, as I suggested, it can be more accurate and faster than humans. The models can be highly granular and detailed in machine learning. You can have tens of thousands of models that predict some aspect of customer behavior. Will they buy a particular product? Or even will an individual executive within a company be likely to buy a particular product? it takes a lot of effort to develop thousands of models, but we have something called automated machine learning now that can generate multiple models and do most of the things that data scientists used to use. Some people call it auto ML. And as I suggested, it can handle both structured and unstructured data. But these models tend to be complex and difficult to understand. The learning is not continuous. As I say, it's episodic. If you develop a model, you deploy it to do scoring. If you want to improve that model, you typically have to go through another round of model development with some new data. In any case, it's going to require a lot of training data. Training data sets can be difficult to create. They have to have that labeled outcome. In a lot of cases, that requires a lot of effort to go through and label, is that a cat or not? These systems don't have any common sense. They don't have any ability to innovate. Some people have started to criticize them for really not using the broader context that the human brain might be able to apply. And because they're so complex, they may require a data scientist. But now that we have tools like automated machine learning, probably less requirements for people who understand the ins and outs of what model is suited to what kind of data.